Hello, I'm Jay Prakash, lecturer of Computer Science and Engineering Department, Government Polytechnic for Women. Today we are going to start the fifth session of Green Computing. So green software. So software is also a major thing involved in the hardware. Okay. So what happens here is a green IT infrastructure is incomplete without green software, and hardware is integrated with the software. Obviously, a software also plays an important role in overall platform energy efficiency. So in consumption of energy, software also plays a major important role. A computing platform is a combination of hardware. So a computation occurs when hardware and the software integrates. The software and other technologies that allows the software to run. Okay, every device runs software and every one of them requires energy to do it. So in order to run the hardware, we need a software. So software is nothing but the number of programs or the collection of programs written in order to perform a particular task. In order to perform the particular task. Okay, every device runs software and every one of them requires energy to do it. In order to run the hardware, it requires energy. Okay, obviously, in order to run the software, the energy is utilized. So you have to minimize the usage of energy. The processor power states. So for a software developers, the CPU is the most important factor. CPU is nothing but the central processing unit. The central processing unit have defined energy states. It has many states. If the CPU is not actively processing the information or not performing the computations, it consumes energy. The CPU should be always in active states and should be run in a proper way. It should not be sit idle. If it sit idle, obviously there is a loss of energy. You have to give lot of work or lot of process to the processor, so the processor performs the action faster and makes utilization of the energy in a proper way, and so that the energy can be utilized for other purpose. The CPU has two states, the C states and P states. C states, the C states, the C naught stands for CPU is active. C represents that CPU is active. It is busy carrying out some task and is performing the task at the frequency. So C states is an active state where it performs the action by with a proper frequency. P states defines the frequency at which the processor is running. So P stands that the processor is running according to the frequency. Okay. Next, P is equal to CV square F. This means that P is the power required to run the CPU and is a product of capacitance C and the frequency F and the voltage V. So the power is calculated by the multiplication of the capacitance, the vector, the voltage, and the frequency. Okay. Next, energy saving software techniques. There are different methods in order to save the energy. Well behaved software allows energy saving features to work, if not lead to the low battery life and high energy costs. So the software should work properly, otherwise the energy is consumed. The energy is consumed. Okay. So it makes the energy consumption more and makes the power consumption more and makes the environment loss of energy. Okay. The active software is a software that is fulfilling its intended purpose. There would be a workload that the CPU is busy working on, idle working on. Okay, that we have to make that CPU is always working on, otherwise the energy will be lost. Okay, the idle software is that essentially running but waiting for the event to make it active. So active software is the software is running at a time, whereas in the case of idle software, what will happens, it is waiting for the event to take action. Okay, the software energy efficiency occurs by computational efficiency. The computational efficiency is done by using algorithms, multi-threading methods, vectorization, and architecture tuning. And the data efficiency can be occurred by asynchronous input output, the buffering, and MCQ methods. The context awareness can be done by AC or DC methods, the threshold methods, or power policies. Ideal efficiency can be achieved by C states, the timer resolution, and the background activity. What do you mean by computational efficiency? Computational efficiency means getting the workload done quickly. That is nothing but the not to perform the action by the CPU in a faster way with a minimal energy consumption. The software performs saves not only the time but also energy. The software should consumes the energy, but it should be lesser so that energy is minimized. The faster we can complete the workload and get the computer to the idle. So what is that? We can perform the action faster and make the computer idle so that other work is allotted to the CPU, it will be done. The more energy we can save. So faster the work done, obviously minimizes the energy, obviously we can save the power. The computational efficiency can be achieved by efficient algorithms, multi-threading, vectorizations are used. So efficiency can be achieved by algorithms, threading methods, and also Vectorization methods. Efficient algorithms. The choice of the algorithms in the data structures affects the application performance. Whichever the algorithm we choose, it should be better. Otherwise, the performance of the computer will be lower. Okay, so we have to perform the algorithm, but that perform better way, so that it will give the result in a faster way. For a particular problem, a stack may be better than the queue, and a B tree may be better than the binary tree or hash function. So whichever the algorithm that executes the program or the task or the functions in a faster way, that programs can be used. The best algorithms or data structures to use depends on the problem study and consideration of the architecture, design and algorithms and data structures. So that depends upon the how the architecture design occurs, the algorithms which suits better that should be selected. Multi-threading. So software with multi-threading features has better performance and also better energy efficiency. Multi-threading means more than one task at a time, so that then the working of the computer will be faster. Multi-threading takes the advantage of multiple cores available in the model computer compute platform. So multi-threading is nothing but more than one task at a time. It is called as multi-threading. A well-balanced multi-threaded workload is more energy. So a balanced multi-threaded means it should not occur for deadlock. So we have to balance the threading techniques and efficient than running the same workload with a single thread. So within the minimal option or minimal time that the task has to be multiple task has to be completed. Vectorization methods. So what happens here? The computational efficiency is achieved by vectorizing the code instead of using scalar method. So instead of going for scalar method, you can go for vector methods. What is the advantage? The vector technique, advanced instructions such as single instruction multiple data can be used. Single instruction multiple data is used. SIMD works with the instruction level data, parallelism, and completes the task faster, hence the saves the energy. So it performs single instruction multiple data, means multiple data can be action can be done by using a parallelism method, so that will help the multiple tasks can be occurred at a time. So it makes the faster computing efficiency and saves the energy. So when it saves energy, obviously the production will be lesser. So this is how the different methods can be used. So thank you, students.